All right, in this video, I want to talk to you about Project 2 and give you some insights into what I'm looking for and what I am hoping that you will be able to learn through the parts of Project 2. Uh, I guess I'll start with the second part of the class is all about distributions. We learn about discrete distributions, continuous distributions, and sampling distributions. And you can see from the questions that I'm going to ask you here, that's what you got to do. And Excel plays a major role in you working in this particular part of the class. So the first two questions are binomials and normals, and I want you to show me how to use, or I want you to show me that you know how to use the binomial distribution functions, the normal distribution functions, and there's two of those. And I'm pretty specific as to what I'm looking for. And so the first question, I give you a little story, and I want you to identify the various components of the distribution. If it's a binomial, which it is, you should tell me the value of n and p that you're working with. When you're working with normals, mu and sigma are the two things that you need to identify, so that doesn't really come into play here. So the first part in question A, I'm just asking you to identify, and then in question B and C, I'm asking you, show me you know how to use the binom.dist function in Excel. And I want you to write out what the function is. You can see in the notes that I've used the binom.dist, and I actually put in the various pieces that you need to answer the question, to show me that you know how to use it. So for the binomial.distribution, there's a value that you're interested in working with. There's a value of n, there's a value of p, and then we're using the version that says true for the cumulative binomial. So go ahead and do that. In question B, you're going to use one binomial distribution function. In question 2, you're going to have to put a couple of them together, but spell it out. Show me what it is you're typing into the Excel spreadsheet, and then go ahead and give me the numerical answers as well. If you want to draw dots, if you want to draw and show me what you're thinking, that's great. If you show me the dots, I'll at least be able to give you some partial credit, whereas if you just give me an answer, if you give me a single number, you're not going to get much credit. I need the binom.dist with the various parameters laid out. In question 2, you're going to be doing some normal work for me. You're going to be using the normal distribution function and normal inverse function, but the normal distribution you're working with is going to be unique to you, because you, in your printout, are going to give me a value of the mean, value of the standard deviation for your mileages. So put in a value of the mean, put in the value of the standard deviation for your mileages. Also, tell me your 10th observation, and this should just say mileage. It shouldn't say size or mileage. Ignore that. It'll be fixed by the time you see it. Give me the mileage for your 10th observation, the mileage for your 60th observation, and then you're going to use them in part A to find the proportion of all mileages. We're going to assume that we have a normal distribution with a mean of whatever your mean is and a standard deviation of whatever your standard deviation is. Now, I know that those are just sample values, but we're going to treat them in question 2 here as if they're population values. And then you're going to talk about, or you're going to tell me through the normal distribution function, how you're using it to find the probability that a randomly selected mileage would fall between the 10th or the 60th observation. The other way, I could say the proportion of all mileages that fall between the 10th and the 60th. Now, if you want full credit, draw me a picture. So get in here, use a drawing tool, print it out, use a pencil or a pen and draw and shade. Put in the value of your 10th observation, put in the value of your 60th observation, shade in between, and then show me where the normal distribution probabilities come into play. And so that's question A. In question B, I want to identify the top 8% of the mileages. So show me where that would be in this picture. Is it on the left? Is it on the right? Show me where the top 8% are located, and then use the normal inverse function. Again, spell it out. Give me the value of the normal inverse function. Tell me the probability you're using. Tell me the value of the mean. Tell me the value of the standard deviation. And then, so I want that actually spelled out, written out, norm.inv, open the parenthesis, put in the probability, put in mu, put in sigma, close the parenthesis, and then tell me what that value is. In part, question 3, you're going to be doing sampling distributions. Again, thinking back to the printout you gave me in question 2. What if you took a future sample of 100 mileages? That's the sample size here. If you took a sample of 100 mileages from your population, what would the sampling distribution of X bar look like? We're going to talk about 3 things. You should tell me where the mean of the sampling distribution of X bar is the mean. You should be able to tell me the standard deviation of the sampling distribution of X bar, and you should tell me what the shape of the sampling distribution of X bar will be. You should tell me what those 3 things are, and those are the 3 things you're going to use in question B to tell me the probability that the sample mean from that future sample of 100 would be less than your 10th observation. So again, using the normal distribution function, you should be able to write out, tell me the value of x that you're using, tell me the mean, tell me the standard deviation. You're going to use true again, but show me the picture, show me the normal distribution function written out, and then give me the answer. And then lastly, in question C here, we've discussed 4 different techniques in class. You should be able to use 2 of them to, and I should say prices, or I shouldn't say prices, I should say mileages. You should be able to use 2 of those to identify whether your mileages are normal or not. And so in question 2, we assume they were normal. Here in question 3C, we're going to check to see if they are. And so we've talked about some chapter 2 plots. And so you could look at a histogram, for instance. We looked at something called an empirical analysis, which requires a lot of work. The IQR divided by S, that one's pretty easy to use. And then there's a normal probability plot, which Excel does not make easy to find. So whatever 2 you want to use, give me the printouts, give me the information that you need, but then take a look at the results you get and assess whether your mileages are normal or not. And that's what you're doing in question or in project 2. If you have questions, the TAs and I are ready to answer them. So get to work sooner as opposed to later. Good luck.